All right, so the first thing I want to do, let's just talk about the test. I'll go through the exam. Overall, the scores were good, but I know, there are always people who scored lower than you hope to or that kind of thing. So the first thing I want to say is if you didn't score as well as you would like to, come talk to me. I think I have some really helpful suggestions about how we can get things back on track. And if you're putting in the expected amount of time and you felt like the score didn't reflect that, I bet I can give you some suggestions that'll help improve it in the future. And remember that this score doesn't even have to count in your grade, because the final exam will replace the lowest score of your 4 previous exams. So if you got a really low score, you can think of it as just like one pass. Yeah, you get a mulligan, So you can think of it as like a way to just calibrate your understanding of how those practice problems relate to the exam, and then just go from there, But yeah, if you're unhappy with your score, please come talk to me in office hours or after class, and I'm sure we can come up with a system that'll get it going. So now I just want to go through all these questions, explain how to do these problems. So exam 1. The first question, ball's thrown up into the air from a height of 3 feet. And it takes 3 seconds for the ball to hit the ground. And we want to know what's the velocity of the ball at the instant of release. Yes? Oh, and I didn't mention this, but if you look at it and you think there was something I didn't see, I didn't score something right or whatever, just the sooner you come talk to me, the better from my perspective, but just come talk to me and we'll straighten it out if there's a problem. So that's what we want. The first thing we have to do, I'm going to convert everything to meters. So 3 feet. To convert that to meters, we'll use the fact that 3.281 feet is 1 meter. And you get a distance of 0.914 meters. So that's the initial starting height. And now we'll make those 4 choices. The time equals 0 instant, the time final instant, the 0 position, and the positive direction. Time equals 0 is going to be when it's released. Time final is when it hits the ground. The 0 position is the ground. And the positive direction is up. So the 0 position is here, and the positive direction is that way. And now we're going to think through what we know and what we want. Time final. We know that the elapsed time is 3 seconds, so TF is 3 seconds. Acceleration, this is a free fall problem. So acceleration is negative 9.81 meters per second squared. Initial position, when time is equal to 0, the position is 0.914 meters in the positive direction from 0. So PI is positive 0.914. Final position is the ground, and that's what we chose as 0. The initial velocity is what we're trying to find, and we don't know or care about the final velocity. The equation that works with these is the one that says P final is equal to P initial plus V initial T final plus 1/2 ATF squared. P initial? So what that means is the location of the object when time is equal to 0. Time is equal to 0 when it's launched. So we need to know the position of the thing when it's launched, and we're told that it's 3 feet off the ground. So it's 3 feet up, which is positive. And then I converted. Yeah. So 0 is equal to 0.914 meters plus VI times 3 seconds plus 1/2 A, that's minus 4.905 meters per second squared times 3 seconds squared. And so you end up with VI times, well, let me keep it on the right sides. Let's see, so positive 4.905 meters per second squared times 3 seconds squared is 9 seconds. You know, the quantity 3 seconds squared is 9 seconds squared, like this. Then minus 0.914 meters is equal to VI times 3 seconds. And then divide both sides by 3 seconds, and you get that VI is equal to 14.41 meters per second. And then the problem asks for it in millimeters per hour using scientific notation. So to get it into millimeters per hour, we take 14.41 meters per second (1 millimeter is 1 times 10 to the minus third meters, and 3,600 seconds is equal to 1 hour. and you get 5.19 times 10 to the 7th millimeters per hour. Any questions about the first one? Yep.
Is the velocity final not zero because you're like, would the velocity final be the instant before it hits the ground?
Right.
Okay.
So anytime you specify velocity final, what you're specifying is the highest spot in the object's motion.
Okay.
That's the only time you use that is for the highest spot. So that's an important distinction to make.
Okay, so velocity final would never be when it's hitting the ground. If it's going up and it's arcing, it's always going to be specified as the highest.
Right. Yep.
Okay.
Any other questions? Okay, so the second one says a ball rolls so a ball's rolling. It starts at a point A and rolls to a point B, where these two are separated by 5 meters. The elapsed time for that motion is 7.5 seconds. And for both of these two questions, we're going to say time equals 0 is the instant the motion starts. And what we're going to do is draw position versus time graphs for both of these. So for the first one, we're going to choose the 0 position at B, and the positive direction is in the direction of motion. Okay, so I'm going to put the 0 position at B and the positive direction this way. If A is 5 meters in the negative direction from B, what's the numeric label for A? -5, yep. -5 meters. And so this ball starts at -5 meters and then goes to 0. So over a time interval of 0 to 7.5 seconds, it starts at -5 and goes to 0, so that's the graph. Any questions about that one? For part B, this time the 0 position is at A, and the positive direction is opposite the direction of motion. So A is 0. The positive direction is this way. And so what's the numeric label for B? -5, yep. It's 5 meters in the negative direction from 0. And so this time it starts at 0, and 7.5 seconds later it ends up at -5. So the graph looks like this. Any questions about that? And then number 3, a car is moving 50 miles per hour. And it stops over a time interval of 0.1 minutes. How far does the car travel during that time? I'm going to convert miles per hour to meters per second and minutes to second and do all the calculations in meters and seconds. So 50 miles per hour. 1 mile is 1,609.344 meters. And 1 hour is 3,600 seconds. So that gives a speed of 22.35 meters per second. And then 0.1 minutes. 1 minute is 60 seconds. So that's 6 seconds. And now we have to choose those 4 things. The time equals 0 instant is when the car starts to brake. Time final is 6 seconds. P equals 0 is the car's location at time equals 0. So it's the car's location when it hits the brakes, and the positive direction is the direction of motion. T final is 6 seconds. The acceleration we don't know, but if we can do it without that, that's fine. So we'll leave that off. P initial, we chose the zero position to be the car's location when time is equal to 0, so PI is equal to 0. What are we trying to find? How far it goes? So what we're trying to find is the final position. V initial is, the speed was 22.35 meters per second, and our positive direction is in the direction of motion, so this is positive. V final, well, at time final, the car comes to a stop, so V final is equal to 0. And now we're looking for an equation that works with these, and there isn't one. So we need to solve for an intermediate variable, and the one we're going to use is acceleration. So we can use the equation that says 2a times the quantity pf minus pi is equal to v final squared minus v initial squared. So 2a, anyone have a question?
I didn't use that equation.
You didn't?
No, I used VF equals VI plus E.
Oh, we know the time. Yeah, you're right. That's not going to work, is it? Well, what are we missing here? We don't know PF.
Yeah.
Right, so we can't use that. So what we can use is VF is equal to VI plus ATF. That's good. We want to use that one when we can anyways. So 0 is equal to 22.35 meters per second plus A times 6 seconds and so 22.35 meters per second divided by 6 seconds is equal to A, and this is negative. So you get A is negative 3.725 meters per second squared. And now we know this one. We can put acceleration in the column of things that we know. And then we can use this equation. PF is equal to PI plus VITF plus 1/2 ATF squared. So PF is equal to 0 plus 22.35 meters per second times 6 seconds plus negative 3.725 meters per second squared times 6 seconds squared. And you get that PF is 67.06 meters.
Could you use either that equation or the other one? 2A PF minus PI?
Yes. Yep. Any other questions on that one? And then the last one, so ball's thrown straight down towards the ground. The height that it's thrown from is 15 meters. If the ball's speed at release is 5 meters per second, what's the velocity of the ball the instant before it hits the ground? So choose the four things. Time equals 0 is when it's thrown. Time final is when it hits the ground.
And just to clarify what you said earlier about velocity final,
Mhm.
being at the highest point, would you be finding velocity final, when it hits the ground, if the positive direction is going down then? Since hitting the ground then would be like the highest point?
No, that's a good question. So that velocity equals 0 thing only works like when the object goes up and then changes directions.
Okay.
So in this case, you can think of it as like there's never an instant where it's at its highest point,
Okay.
Position equals 0 is the ground, and the positive direction is up. Time final, we don't know. Acceleration, this is a free fall problem, so A is negative 9.81 meters per second squared. P initial is positive 15 meters. P final is 0. V initial, we know that when it's thrown, its speed is 5 meters per second, and we know that it's thrown down. Our positive direction is up, so this has to be negative. And then V final, we don't know that. I guess that's what we're looking for.
Is it okay to make your positive direction down?
Yeah, I wouldn't, though. But mathematically, it's fine.
Okay.
The thing is, like, if you always do it the same way, you're less likely to make mistakes.
Okay.
And if you always do it the same way and it's opposite what I do in class, that's being unnecessarily contrary.
Okay.
But yeah, it works fine, yes. So 2A times the quantity PF minus PI is equal to VF squared minus VI squared. So 2 times negative 9.81 meters per second squared times the quantity 0 minus 15 meters is equal to VF squared minus negative 5 meters per second squared. And so you get positive 294.3 meters squared per second squared is equal to VF squared minus 25 meters squared per second squared. Add 25 to both sides. I think that's 319.3 meters squared per second squared is equal to VF squared. And now take the square root of both sides, and you get that so you get 17.87 meters per second is equal to VF, but you're taking the square root of both sides, so this has to be plus or minus, and then you have to have a reason for choosing the plus or the minus. In this case, the object's moving towards the ground, which is our negative direction, so we want the negative. Any questions about that one? Okay. Any other questions in general about the test? So now we're going back to 2D kinematics. We did the example last time where a baseball was thrown at a known angle from a known height at a known speed, and we used that to figure out horizontally how far the ball went. So now, let's say that this person's on a unicycle. Holding a ball. Let's see. What does a unicycle look like? Okay, so this guy is riding the unicycle this way. And on the floor, this is like fraternity hazing. There's a cup on the floor. And the question is, for, oh, and I guess this, we'll give a height for this cup. We'll say that that's 0.15 meters from the ground to the top of the cup. And we'll say that the distance from the floor to the ball is 1 meter. And we'll say that the unicycle is riding 5 meters per second. How far, let me rephrase this. So how far away from the cup should the ball be released to land in the cup? Any questions about the setup? So first we have to make those 4 choices. So time equals 0 and time final. And then in 2 dimensions, instead of position equals 0, we have to choose the origin location. And instead of choosing the positive direction, we have to choose the coordinate system orientation. So what do we want to choose for when the ball is released? No, I gave away the answer. Time equals 0. Let's make time equals 0 when the ball is released. Time final is when the ball reaches a height of 0.15 meters. So, in other words, yeah, when the ball would reach the cup if it was a good shot. For the origin location, I'm going to choose the height of the ground right underneath where the ball's released. So on the ground beneath the release point. And for the coordinate system orientation, we're always going to choose the y-axis pointing up. That means the x-axis is always horizontal in some way, and I'm going to choose horizontal in the direction of motion. So y is up, x is horizontal in the direction of motion. Now we have to think through all the things that we know and want to find. We have to go through a longer list now in 2 dimensions of variables. Do we know time final? No. If we can get away without it, that's fine though. Do we know anything about acceleration? It's free fall, so as long as the y-axis is up, which is what we're always going to choose, ax is equal to 0, and ay is equal to negative 9.81 meters per second squared. The position when time is equal to 0, that's the position of the ball when it's released. How far horizontally from the origin is the ball when it's released? None. So the x component is 0. Vertically, how far is the ball from the origin? 1 meter. And then do we know anything about P final?
Well, that's what we're looking for, right? Well, yeah.
We know that the y component is 0.15 meters. What we're looking for is the x component. Question? Okay, so PFY is the height of the cup, so 0.15 meters, and PFX is what we're trying to find. Do we know anything about V initial? That's right. So anytime something's dropped, then at the instant it's dropped, the velocity is the velocity of the vehicle or whatever it's dropped from. So we know that the speed is 5 meters per second, and the direction that the unicycle is going is straight horizontal in the positive x direction. So VIX is 5 meters per second. And VIY is 0. You can think of it this way. This is the direction of motion. And so the velocity is a vector in that direction with a magnitude of 5. And if you think of cosine and sine, think of what the angle is from the x-axis that you need to get here. It's 0 degrees. So you end up with an x component of 5 and a y component of 0. Anyone have any questions about that? Want some clarification or anything? Bless you. And then do we know anything about the final velocities? Nope. So this is it. Is there an equation that works so we can find PFX? Not usually, and sometimes there will be, but in this case, there's not. So we're going to first try to find TF. And to find TF, we can use PFY is equal to PIY plus VIYTF plus 1/2 AY TF squared. So that says 0.15 is equal to 1 plus VIY is 0 plus 1/2 AY TF squared, that's minus 4.905 TF squared. If you subtract 1 from both sides, you get negative 0.85 is equal to negative 4.905 TF squared. And so TF is equal to 0.416 seconds. I got that by dividing both sides by negative 4.905 and then taking a square root. When you take that square root, you get a plus or minus. So how do I choose the plus or the minus for TF? Yeah, that's time, so we know we always want the positive one. And now we know that TF, we can consider that one more thing that we know. And now we can use the equation that says PFX is equal to PIX plus VIX TF plus 1/2 AX TF squared. So PFX is equal to 0 plus 5 times 0.416 plus all of this goes away because AX is equal to 0. AY is negative 9.81, but AX is 0. So that all goes away. And we get that PFX is equal to 2.081 meters. So this distance here, that horizontal red distance, if that ball's going to land in the cup, that needs to be 2.081 meters when the ball's dropped. Yeah. Okay, so I'm sort of thinking at this point that you're just going to stop worrying about carrying the units through. It's fine with me now. We did it for a while, and it would still work. But you can just leave the units out of the calculations. But the way it would cancel out is this would be meters per second squared. This would be meters. Oh. This negative 4.905 has meters per second squared. This has meters. So if you divide, you end up with something seconds squared equal to TF squared. And then when you take the square root, you get just seconds. So it will work out, but feel free to skip that now. If you ever need to get a problem right, carrying the units through is a good way to, like you feel a little more confident if your units work out. So it's a good way to sort of check that everything's going right, but you don't have to do that anymore. Okay, so here's what I'd like to do. I think this will probably take about the rest of the time. But let me do another problem, and I'd like you to see how much of it you can think through. And then after you get some time to do it, I'll do it. It might have to be Thursday. And it's going to have to do with a helicopter because those are fun to draw. That was so fun. Try it. Okay, so that's a hand coming out of the elevator, dropping a ball, whatever, some kind of object. The helicopter is moving at 15 meters per second. at an angle of 20 degrees below horizontal. And the object is dropped from a height of 30 meters. So the first question is, how long does it take for the object to hit the ground? Okay, so see if you can work together on that, make sense out of that, and after I give you a while to work on it, I'll go through it. If you get